seniors, welcome back. We're still in 8.1, except this time we're doing substitution, solving the system by substitution. I wrote down the 4 steps. Again, they're on eCampus. You don't have to worry about writing them really fast right now. Just pay attention. Step 1 is you're going to solve one of the equations for one of the variables. If it's not already done for you, half the time it is. Sometimes it's not. If it isn't, make sure you pick a variable that has a coefficient of 1. Otherwise, you're going to end up with a bunch of fractions. Make it 20 times harder on yourself. Make sure it has a coefficient of 1. Step 2, once you solve it, take that expression of what y equals or x equals, it doesn't matter which variable, and plug it into the other equation. Step 3, solve, like you normally would solve an equation. 4, take the value that you get and plug it into the other equation to solve for the other variable. Okay, so here are the 4 steps. Make sure you write them down, guys. Don't forget, you're still going to need this for your 9-week exam. So get all of my notes off of eCampus, write them down in your notebook so that you have them. Okay, let's look at this problem over here. This is one of the easiest substitution problems because both of them are already solved for you. This is probably the only time I would use substitution because it's so easy. Y equals 3x plus 5 and y equals 2x minus 3. Of the 3 different substitution problems, this is the easiest. What you do is you set them equal to each other and solve. So if y equals 3x plus 5 and y equals 2x minus 3, that basically means that 3x plus 5 equals 2x minus 3. And then from here, you're just solving a multi-step equation where you have variables on both sides and numbers on both sides. So let's solve for x, okay? I have 3x here, 2x here. I'm always going to go for my positive variable, so I'm going to subtract 2x off of both sides. 3 minus 2 is 1. Bring down everything else. Since I'm solving for x and 5 is being added to x, I'm going to subtract 5 off of both sides. And x equals minus 3 minus 5 gives me minus 8. So I know what my x equals, but I'm not done. Remember, the answer to a solution is an ordered pair. I need an x and I need a y. So in this case, it really doesn't matter which one I plug it into. Whatever makes you happier that day, I'm going to plug it into the top one. Y equals 3 times negative 8 plus 5. 3 times negative 8 is negative 24. Bring down the plus 5. Minus 24 plus 5 is negative 19. So I now have my x and I have my y. My final answer is negative 8, negative 19. This is my final solution. Okay? Now this is, like I said, the easiest when you have both variables solved for you. Also make sure they're the same variable or it doesn't do you any good. Okay? Now sometimes you have where only one of them is solved for you, and sometimes you have where none of them are solved for you, where you have to solve for one of the variables. So let's look at this example. X minus 3y equals 2, and negative 2x plus 6y equals 2 as well. All right? Nothing is solved for me here. So I'm going to look at my 2 equations, and I'm going to find the variable that has a coefficient of 1. This is what I want to solve for. Okay? So I'm going to bring that equation down. And it's also the easiest because all I got to do is add 3y to both sides. And I get x equals, again, I don't get 5. I don't get 5y. These are unlike terms. This is a whole number. This is a variable term. So I get 3y plus 2. Okay, I have now solved for one of the variables. That was step 1. Step 2 says take that expression and plug it into the other equation. Do not plug it into the equation that you were just working with, okay? Take the other equation and whatever you've got here, since that's what x equals, plug it in for x. 3y plus 2. At this point, you should only have one variable. If you still have an x and a y, you did something wrong, okay? The reason you do the substitution is to eliminate the x and the y, and you're left with only one. Whether it's 2 x's or 2 y's, they should be the same, okay? Here we're going to distribute and get negative 6y minus 4, bring everything else down. Okay? Now what do you notice? I notice a minus 6y and a plus 6y. I can cancel those out. Okay? Minus 6 plus 6, they cancel each other out. You get 0. Okay? Then I have negative 4 equals 2. Is that true? Well, no, it isn't. So this is a false statement. If negative 4 does not equal 2, what sort of solutions do I have? Well, if all of my variables are gone and all I have are numbers and they don't equal, I get no solution. Okay? If I've gotten rid of all of my variables and all I'm left with are whole numbers, then my answer is no solution. Okay? If you have any questions, you can post a question in the comments section or email me. But I have one more problem to show you. I'm going to leave this one up for you to look at for a second. The last problem is 9x plus 3y equals 15, and 3x plus y equals 5. Okay, here again, I'm going to look at my system, and I'm going to find the one variable with the coefficient of 1. The coefficient is the number in the front. So this is the equation I'm going to start with. 3x plus y equals 5, and I'm solving for y. We've done this many times. It's just putting it basically in the slope-intercept form. Y equals negative 3x plus 5. Box that off. This is what you're going to plug into the other equation. So if I write 9x plus 3, where I see y, I'm going to put the parentheses, because this is what I'm going to plug in right here, and this equals 15. Okay? Negative 3x plus 5. So if you see here, I have 2 x's. My y is gone, and I now have 2 x's. So I'm going to bring down the 9x. I'm going to distribute the 3 to the negative 3x and then to the 5. Bring down the equals 15. Okay, 9x minus 9x, those cancel. And I'm left with 15 equals 15. So you ask yourself, is that a true statement or a false statement? It's true. So when you have a true statement, that means any number that you plug into these two systems, it's going to work, which means that any number, all numbers, infinitely many solutions. Okay, so any number I plug in here will work, but no number I pick will work. That's why there are no solutions here. Doesn't matter what number in the universe, nothing is going to work. Here, anything is going to work. And that's the difference between no solution and infinitely many. Okay? That concludes substitution. If you have any questions again, You could always watch the video from Khan Academy, or you can email me. Thanks, I'll talk to you soon. Bye.